On page 299, we've got a situation that they set up at the start of the problem that's going to lead to three different related rates problems. So let's start by looking at the first part right now. All right, so here we've got a ladder 25 feet long leaning against the wall of a house. And the base of the ladder is pulled away from the wall at a rate of 2 feet per second. So let me draw a diagram of that just to make sure I understand what's going on. So there's my wall and there's my ladder. I'll put some rungs on my ladder, and then we'll draw in the section between the base of the wall and the base of the ladder. All right, so we've got the ladder being 25 feet long. And what are the things that are changing in this problem? So the base of the ladder is getting pulled away from the wall, so this distance is changing. I'm going to call this X. And as that's getting pulled away, the top of the ladder is going to slide down the side of the wall. So I'll call the height of the top of the ladder Y. Okay, so these are the things that are changing, X and Y. And what do we know about the rates of change? So you notice that even though we don't have the graphic organizer that they set us up with in the previous problems, we can keep on thinking about them. So I'm going to go through them in the same order. So the base of the ladder is being pulled away from the wall. So it's going that way at a rate of 2 feet per second. So how do I express that in calculus language? Well, I've got dx dt is equal to 2. Positive 2 or negative 2, do you think? Well, this distance is increasing because the base is getting pulled away. So the distance between the base of the wall and the base of the ladder is increasing. So let's call that a positive 2. And we want to know what dy dt is equal to. We want to know how fast the top of the ladder is sliding down the wall when the base of the ladder is 7 feet from the wall. So when x is equal to 7 is equal to question mark. All right, so what is a relationship that ties x and y together? And that's a right angle because this building was built properly, that wall is coming straight out of the ground. So we've got a right triangle here. So the relationship that we want to deal with is the Pythagorean theorem. So we've got x squared plus y squared is equal to 25 squared. And so what we can do is we can differentiate both sides of this with respect to time. So the derivative of x squared with respect to t is 2x times dx dt. The derivative of y squared with respect to time is 2y dy dt. And the derivative of 25 squared with respect to t is what? Well, this is just a constant. So the derivative of a constant is equal to 0. All right, and so what we know here is we know that x is equal to 7. We know that dx dt is equal to 2. Can we solve for dy dt right now? Well, we don't have quite enough information yet because we also need to know what y is equal to. And so sometimes I like having a second diagram that comes along with this. And the second diagram is going to look almost like the first. But the first thing I want to think about in this time is that we're thinking about this at all times. This is the relationship between x and y at any moment in time while we're dealing with this 25-foot ladder leaning up against the wall. But I'm going to make another diagram that talks about the specific instant that they're curious about. So this is our snapshot view. We're talking about a snapshot view when the base of the ladder is 7 feet from the wall. So this is x is specifically equal to 7. Can we solve for y in this case? How do you think we can do that? Well, this is still a right angle. The hypotenuse is still a ladder that's 25 feet long. So instead of using this relationship, we can use this one to solve for y because we know what x is and we want to know what y is. All right, so let me write 7 squared plus y squared is equal to 25 squared. All right, and I'll grab my calculator. So 7 squared is 49. I don't need any help for that one. 25 squared, I know that one's 625 off the top of my head. But maybe I need a little help. 625 minus 49 All right, so y squared is equal to 576. And so that says that when the base of the ladder is 7 feet from the base of the wall, I know that the distance from the top of the ladder to the base of the wall is 24 feet. All right, so when x is equal to 7, I know that y is equal to 24. And now I've got enough information to fill this out. So I've got 2 times x, at this moment that's equal to 7, times dx dt, which is 2, plus 2 times y, which is 24, times dy dt, which is what I want to solve for. I want to know how fast the top of the ladder is moving down the wall. And that's equal to 0. So 2 times 7 times 2 is 28, plus 2 times 24 is 48, dy dt is equal to 0. So that becomes 48 dy dt is equal to negative 28. And so dy dt is equal to negative 28 over 48. And I'll simplify that. Both sides I can divide by 4 to get negative 7 over 12. What's my unit for this? I'm talking about the change in some distance, the height of the wall between the top of the ladder and the base of the wall, and time. So the rate of change between a unit of distance and a unit of time. My unit of distance in this problem is feet, and my unit of time is seconds. Am I concerned that this is negative? It's always something good to think about, just a little sanity check for your work. But when the base of the ladder is getting pulled further away, the ladder is sliding down the wall. So the distance from the top of the ladder to the base of the wall should be decreasing. So a negative rate of change of that height is something that's totally appropriate. All right, in the next video, we're going to tackle part B of this, where we're going to be looking at the same situation, the same moment in time, in fact, but we're going to be talking about a different function that we need to differentiate. So that'll be interesting.